Sketch the graph of y equals 7 to the power x, for x belongs to the real number line, showing the coordinates of any crossing point, of any points at which the graph crosses the axes. And then solve the equation 7 to the power 2x minus 4 to the 7 to the x plus 3, giving your answer to 2dp where appropriate. So let's have a look at this then. So this sketch here, let's do a little sketch. I'll just draw it in here. Here's the sketch of y equals 7 to the x. And we know that the coordinate here, if this is the x-axis, this is the y, this is 0, and this would be, when x is 0, we get 7 to 0 is 1, so this would be, when x is 0, y is 1, and that would be the only point where it crosses an axis. So that's part A done. Part B, here, we've simply got a quadratic using the properties of indices. We can write 7 to the 2x is 7 to the x squared, using the power rule. Now this is a quadratic in 7 to the x, isn't it? So we can simply factorize it, hopefully, and see what we get. Here we'll have 7 to the x times another 7 to the x here. And then we've got 3, so it has to be 3 ones. And we've got minus 4, so that has to be a minus and a minus. So 7, this time, expand the bracket then, 7 to the x times 7 to the x, we'll give this squared. Minus 3 lots of it, minus 1 lot of it, makes minus 4 lots of it. And then minus times a minus is a plus, 3 ones are 3. So that's what we've got there. So that tells us that 7 to the x equals 1. And we know when that is 1, when x is 0. So that tells us x equals 0 here. And the other one tells us that 7 to the x is equal to 3, isn't it? Now we'll take logs. So log of this side is x log 7 is equal to log 3. So that tells us then that x is equal to log 3 divided by log 7. We can type that in a calculator. So it's log 3 divided by log 7 equals, now we're working to 2dp where appropriate, 0.56, isn't it? 0.56. Okay, and we can tap that in a calculator just to check. So let's do that then. 7 to the power 0.56, and we should get something approaching the value 3, which we do because we're just rounding off, aren't we? 2.97. So that's what we get because it's approximately right, because we're only doing it to 2dp.